the first thing you're going to need is your periodic table. And you will also need your calculators and your journals. All right, go get it. Pause. All right, so what do these three formulas have in common? Let's think about it for a minute. CH, C2H2, and C6H6. Well, think about it. You got it? That's right. They each have the same ratio. They each have a 1-to-1 ratio. 1-to-1 ratio of carbon atoms to hydrogen atoms. The formula CH is the empirical formula of all of C2H2 and C6H6. This one right here is the empirical formula. All right, so we're going to come back over here, and we're going to say then that what the empirical formula is the simplest formula with a whole number that contains the same atom ratio. So one side note to remember, all ionic compounds are written with their empirical formulas. That is the rule of thumb for ionic compounds. They are written to the simplest whole number ratio. Molecular compounds are not written that way. But going back to empirical formula, this formula is N2O4. Therefore, think about this, pause. What is the empirical formula of this number or this formula? Pause. Write it down. Now, the empirical formula of this compound is NO2. Still have the same ratio, 1-to-2 is the ratio here, 2-to-4 is the same as 1-to-2 ratio. Now, pause once more and calculate the empirical formula of this compound. The empirical formula of this compound is CH2O. Notice 12, 24, 12. So I divided this by 12, this by 12, this by 12, and it gave me a ratio of 1-to-2 to 0. Now, the next one. What is the empirical formula of P2O5? Pause. The empirical formula of P2O5 is P2O5. It cannot be reduced any further. The ratio is 2-to-5. All right, so what does this mean? To understand how to do empirical formula problems, you have to think about the following example. Let's suppose you have 1 mole of water, H2O. What does it mean to have 1 mole of water molecules? Well, it means 1 mole of water means to have 1 mole of molecules. In other words, 6.022 times 10 to the 23rd molecules. It means that we have 1 mole of H2O molecules, right? 1 mole of H2O molecules. And in this 1 mole of H2O molecules, there are 2 moles of hydrogen atoms to 1 mole of oxygen atoms. So we know that H2O, once more, has 2 moles of hydrogen atoms to 1 mole of oxygen atoms. So the ratio is 2 moles to 1 mole. Therefore, a 2-to-1 ratio, which is the same ratio that the chemical formula has, H2O. Now, if you're given a different number of moles, could you calculate this formula? Sure, as long as the ratio is 2 to 1, we will have the formula shown as H2O. That's exactly what we're going to try to do. Let's suppose for a minute that we have 0.378 moles of H2O. In this example, the total moles of hydrogen is 0.756 moles. And the total moles of oxygen is equal to 0.378 moles. The ratio of hydrogen atoms to oxygen atoms is 0.756 moles to 0.378 moles, which would be equal to a 2 to 1 ratio, which is still the same as the chemical formula. So here's the point. If the compound is pure, then all you have to do to determine the atom ratio is to find the moles of each element in the compound. That takes the ratio of the moles. So basically, if you are given the mass, all you have to do is to calculate the moles, convert mass to moles, find the ratio by dividing each mole by the smallest number, or the smallest number of moles. And at this point, you round to the nearest whole number. Unless too far to round, in that case, we have to multiply by a number that will give us a whole number. But we'll come back to that a little bit later. And then we determine the empirical formula. Pause and write these steps. All right, in this problem, we're going to determine the empirical formula of a compound composed of 36.5% sodium and 24.4% of sulfur and 38.1% oxygen. Since percent is based on 100%, we can convert the percentage signs to grams and base it on 100 grams of the compound. So if we had 100 grams of the compound, we would know that 36.5 grams would be sodium, 24.4 grams would be sulfur, and 38.1 grams would be oxygen. So we can just make that conversion directly. So we're going to take 36.5 grams of sodium and then 24.4 grams of sulfur and 38.1 grams of oxygen. We're going to convert grams to moles. Well, how do we do this? Remember, we can say grams of sodium to moles, because that's what we're trying to work on, converting grams to moles. And we're going to find the mass of sodium on the periodic table. So go ahead and pause. I want you to work this problem with me. Pause as we work through the problem each time so that we can together work on the right answer. Don't just watch me do it. I want you to also work with me so that you're practicing at the same time. All right, so the mass of sodium based on the periodic table is 22.99. Go ahead and find the same for sulfur. 1 mole of sulfur over the mass of sulfur, which is 32.07 grams. That's sulfur. And finally, we have 38.1 grams of oxygen. We're going to convert to moles. 1 mole of oxygen divided by 16.00 grams. Pause once more and go ahead and solve for these values. All right, so when we carry out this operation, our answer is 1.59 moles of Na. And I hope you have worked these out yourselves. The answer is 0.761 moles of sulfur. And finally, we have 2.38 moles of oxygen. Note that I rounded off to the nearest 3 significant figures because the given numbers were 3. Even though we rounded these to 4, we go with the given numbers. Now, the next step is to find the ratios. And the ratios, this is our second step, we find the ratios by dividing each one of the moles by the smallest ratio, the smallest number. So we're going to say 1.59 moles divided by 0.761 moles. So, and then my next ratio is 0.761 moles to 0.761 moles. And finally, my last ratio is 2.38 moles to 0.761 mole. My ratio here, rounded off to the nearest whole number, is 2. It actually comes out to 2.09, which is very close to the whole number 2. This comes out to exactly 1, and this comes out to 3.17, which rounds off to 3. Now, if we round it off, if it came out to 3.5, what we would have to do is to multiply everything by a number that would give us a whole number. In that case, it will be 2. But in this case, we have a 2:1:3 ratio. So my formula is Na 2 S1, and of course I'm going to put a number, O3. This would be my final answer. Na2SO3, sodium sulfite. This would be the empirical formula. And notice this is an ionic compound, therefore this is going to be the formula of choice. Okay. Review what you have learned, and when you feel ready, go on to part 2 to learn about molecular formulas.